Ingenuity represents the most remarkable things that humanity is capable of. These achievements are not just the product of pure determination, they are a combination of human perseverance and ingenuity.
Hi, Vanessa. My name is Mimi Ong. I work at NASA Jet Propulsion Laboratory, JPL, and my job there is project manager for Mars Helicopter. Mars Helicopter is a technology demonstration flight experiment that Mars 2020 Perseverance rover is hosting. And we're going for the attempt at flying the first ever flight on another planet. So I've been really excited about this phone call to talk to you because I'm getting to share with you the news that your proposed name has been chosen as the name for Mars Helicopter.
Wow, that's amazing.
So on behalf of our entire Mars Helicopter team, I'd like to thank you for our name for our Mars Helicopter, Ingenuity. It's a perfect name for us. We love the name, so thank you.
Thank you, guys. Ingenuity is what allows people to accomplish amazing things, and it allows us to expand our horizons to the edges of the universe.
The Ingenuity mission. To me, this is the little helicopter that can and will, and I cannot wait to celebrate everything that is part of this engineering marvel. Joining me today is Josh Ravitch.
All right. Yeah, thanks so much for having me. Really excited to be a part of this. Certainly as an engineer, I'm not, so used to being on a internet webcast, but we'll do what we can. Yeah, so I'm a mechanical engineer, and I was on the mechanical engineering team for the Ingenuity helicopter. My job was to help with the mechanical design of a lot of the JPL components. And then how does that fit together with the entire rotor assembly? How does that stow onto the rover? How does it deploy from the rover? How can we survive a rocket launch, as well overseeing through tons of testing, integration to the rover, deployment from the rover, reintegration to the rover, just a lot of mechanical handling on the vehicle.
I love this one comment that I have heard, and I believe it was Havard Grip, who's Ingenuity's chief pilot at JPL, say that the Wright brothers showed that powered flight in Earth's atmosphere was possible using, an experimental aircraft. But with Ingenuity, we're trying to do the same thing on Mars, correct?
Yep. Yeah. The project likes to call it the Wright brothers moment. We hope we have one. Yeah, it would represent the first powered aerial flight on someplace that's not Earth. So it would be pretty great if it works. No promises. We're all hopeful. We did our, we've done our best. We think we have a really great, great vehicle ready to go. But long way from here to there. So
how did you come up with how much it should weigh and how fast those rotor blades are going to go?
Yeah. So it is a tech demonstration mission, so a technology demonstration mission. So it is intended to be kind of lower cost, higher risk mission. There's not really a science goal on it. There's engineering goals that we want to demonstrate. And so because of that, that higher risk that we've taken, we're able to keep things smaller. We're using some technologies that we normally wouldn't use on, like the Perseverance rover. You need that thing to be as golden as possible. It's got to work. So there's a lot of work and time that goes into verifying it, making sure the reliability is good, and give us a lot of confidence that it'll be able to handle anything that happens. Helicopter, yeah, we've learned a lot. We spent a lot of time engineering it since the original concepts were actually, I think, in the late 90s, which I was in school. I was in high school at that time. So
and if I'm mentioning this correctly, it was called Marv. Is that true? It was something.
You might know more than I do about this.
And I did a bit of reading, and it's like this original concept, and I can't remember exactly what the acronym stood for, but it was this Martian aerial something vehicle, roving vehicle, or rotor vehicle. It was Martian aerial rotor vehicle, and it was a concept, and so it appears. So if anybody's out there and you had a great idea, 20, 25 years ago, don't throw away that paper. It could become good science someday. But to me, this is the most profound thing, that we're always scaffolding, we're always building and standing on the shoulders of those thoughts and kind of like thoughts and giants of, engineering that come before. So take us through. So you had like a little bit of an idea and a prototype, but again, that's late 90s stuff. What's that like sitting down as you're the lead mechanical engineer? Hey guys, we're going to make a helicopter.
So, I don't know if you've talked to our chief engineer before, Bob. He's kind of the mastermind behind this project, and him and Mimi kind of shepherded the entire nationwide team to do this. It was quite an adventure. Before I got on the job, I joined the team in late 2016. They had done a tiny little vehicle about hand-sized, just to demonstrate that you could fly in a vacuum at all. They put it in a vacuum chamber, turn it on, kind of hops around. I actually have a video that I could show when we get to that point if you'd like to see of a few of these. Demonstrated that worked great. So from there, next step, can you control it at all? I mean, this thing just kind of bounces around. But so they built a full-size mock-up that was just basically a rotor system with a power cable attached to it. Flew that in a vacuum chamber. All the control came from off-board, from computers, and that worked too. That was in about mid 2016. At that point, we're like, oh wow, we can actually control a vehicle, a helicopter in a Martian environment, in the Martian atmosphere. So the vacuum chamber pumped down to Martian atmosphere and filled with similar gases. So it performs kind of like Mars, we hope, anyways. You never know till you're there.
True, but it's like, to me, it's like, so we've talking about the Martian atmosphere. We're talking 95%. Carbon dioxide, maybe truly 1% of the Earth's atmosphere. When did you guys realize that you're going to have to make those rotor blades go 5 to 6 times faster than any helicopter you'd ever fly here on Earth?
I'm pretty sure that the early concepts realized that. I mean, they knew that the atmosphere is so low, right? Like you said, 1% of here, it's equivalent of around like 100,000 feet on Earth. To put it into perspective, so 3 times higher than you'd fly in a commercial airliner. So they knew, and that's actually one of the biggest problems on this was low atmosphere. You need a lot of lift. So yeah, giant blades. Picture, you see the blades are disproportionately sized relative to the helicopter, and that's to get as much lift as possible. We also had to fight mass. Gravity is only a third of Earth, but because the atmosphere is 1/100th of Earth, you really need to cut down as much mass as possible to keep up your lift and be able to overcome your own weight. And that was really the problem that we ran into in late 2016 when I joined the job. The mechanical engineering team, we were given the task of, okay, we've shown that this rotor system can be controlled in a Martian environment, but now you have to take everything on it that has to go to Mars with it. So all the electronics, all the batteries, by the way, batteries are pretty heavy. Solar panel to recharge it, get power, all the things that it needs to be able to survive launch, to be able to, on a rocket, as far as I know, it's not very common to launch helicopters on rockets, especially off the planet. So that was another challenge, as well, to survive the night. Earth is mostly pretty balmy, but Mars at nighttime can get down to in the minus 90 Celsius range. So very cold. Colder than most of our components are really supposed to work at.
And that's one of the things that I read, that is actually one of the greatest power drains on the helicopter, is surviving a Martian night.
You're absolutely correct. Our flights are roughly 90 seconds is the planned flight time, somewhere in that range. But the majority of the battery power held on the helicopter in a given day is used to just stay warm, survive the night. We built a giant wind wall in this vacuum chamber. Chamber is about 15 feet tall, I think, something like that, and had a ton of fans on it to blow air at the helicopter. So yeah, they spent the test team spent a few months up there playing around with that and trying to be able to control in the expected wind speeds. So there's not a person on the ground who's able to fly it, right? You can't joystick it because the mission's the flight is over before you've even told it to go at that point. So the way the mission works, we give a flight plan to the helicopter, and of course, as you said, check the weather first with the Perseverance team. Assuming we're all good on weather and temperature and other environmental conditions. Send the command to the rover. The rover sends the command to the helicopter over an antenna, and says, here's your flight plan. Then helicopter figures out the rest. We'll stay within a couple hundred meters of Perseverance rover, something in that range. Why
don't you share some of your pictures and your slides? Because to me, when I see it visually, again, I think everybody's going to even appreciate the genius that is your engineering. I mean, it is really a marvel, and it's going to add an entirely new dimension of exploration once this works.
Sometimes you have to do something just to show that you can do it. When the Wright brothers flew for the first time, they flew an experimental aircraft. And in the same way, the Mars helicopter is designed to show that we can fly powered helicopter flight in the Martian atmosphere.
From day one, this was the unwavering dream of our team, to get our helicopter launched to Mars so that we can get that opportunity to do that very first rotorcraft flight test in the actual environment of Mars. It's extremely difficult to fly at Mars because the atmosphere is so thin. Compared to Earth, at Mars it's less than 1%. So the first and foremost challenge is to make a vehicle that's light enough to be lifted. And then the second is to generate lift. The rotor system has to spin very fast. 2,000, 2,200, 2,400, 2,600. We're spinning between 2,000 and 3,000 revolutions per minute, and it takes a lot of energy. So it's that balance of a very light system, yet having enough energy that's needed to spin the rotor so fast to lift, and on top of it, having to design in the autonomy.
It has to be fully autonomous from the time it takes off to the time it lands. What we do on the ground is we plan the flights, and so we determine from here where we want the helicopter to go.
Our experiment window is 30 Martian days. So we have planned up to 5 flights of incremental difficulty.
The very first flight, the main thing is we want to get the legs off the ground, and so we will basically go up about 3 meters, and we'll hover there, and then we'll come down again, and that will be the first, really major milestone.
Most of our flights will be at the 3 to 5 meter height. We will be going horizontally again at a few meters per second, probably go out, 50, 70 meters and come back. In successive flights, we'll probably push that further, try to go further. So our priority will be to get back engineering telemetry and not so much images, but I'm sure we'll return a few, because they'll always look cool.
At this point, we've tested all we can on Earth. We have mathematical models that shows how it'll fly at Mars, and we've tested it in the simulated environment that we can create on Earth. It really is time now to do the real flight tests at Mars.
Nothing is a given, but we have done everything we can in terms of a test program here on Earth. The vehicle's performing extremely well so far. It's been doing exactly the right thing, even right now when it's bolted onto the Perseverance rover. So there's a very good chance that we'll pull it off, yes. but it's still high risk, and none of us forget that you could have a glitch that, could mean end of mission, yes.
It's going to be exciting, reacting to any surprises we have. We can't wait. What's really most important is everything we're learning here is for the future rotorcraft systems that we want to introduce into space exploration.
But it's just such an honor to be able to work on something like this. It's genuinely once in a lifetime opportunity. So here's a quick little video. Hopefully the sound comes through all right. Just to show kind of an artist concept of of the mission. This actually does look very close to the flight helicopter. So the basic idea: rover drops us off on the surface, drives away. After our checkouts are done, helicopter flies its missions. And actually a video in a minute that has the some of the videos from the chamber. You can hear the blade sound. You can actually hear it, and it's quite possible. I think Perseverance has a microphone, so it's quite possible you'll be able to hear, no promises, but you might be able to actually hear the helicopter on Mars. There's very little that's non-essential for function. For function, we have a rangefinder, like an altimeter to tell how high we are. We have accelerometer, gyroscope package to tell where we are and try to figure out our position. As well, we have a black and white camera for navigation that faces down. It has the only thing that's not essential for flight. We have one color camera that's intended only to take pictures and send them back to Earth. It's aimed more, the black and white camera is kind of aimed down. You can't really see it in this picture, but you can see the little notch on the right side of the bottom box. That's the color camera. It aims out at an angle that we hope will give us okay pictures. Yeah, and that's about it. It's actually pretty simple otherwise. We didn't have a lot of mass. As a technology demonstration, we just wanted to prove this works, right? We don't want to do anything else that we don't need to do. We don't have the mass to be able to carry extra stuff on this vehicle. Total mass for this is about 1.8 kilograms, about 4 pounds. So less than a 2-liter bottle of soda. The project manager gets annoyed when I describe it that way, but it's really easy for people to conceptualize.
What is its big #1 mission goal?
So actually, really just learning what it takes to fly on Mars is the primary goal. This is to demonstrate the technology works. Even just one flight of up and hover, we'll learn so much about the environment. Even just sitting on the surface, we'll learn so much about thermal control. Can we stay warm? How do we stay warm? Did what we do work? Even what we've done so far, how do you package a helicopter with a lot of very different types of technology than we normally use to survive space flight to another planet? So all that stuff will feed into the potential next mission. If there's another helicopter, include payloads on it. There's a lot of potential feature applications. There's scouting for rover. There's scouting for possible manned exploration on Mars in the future. There's remote sample acquisition. You can fly somewhere you can't fly, or you can't go to with a rover or even a human, down into a ravine, up a mountain. You can get visual, a bird's eye view from the 10 to 30 meter height range, kind of up there where right now we see the surface. You can also perhaps even go to sensitive areas where you don't even want to touch the surface and fly over them and take a picture.
Could the air movement from the blades of Ingenuity be used to clean off the solar panels on the rover?
So this rover is powered with RTG, not with solar panels, but that is a great idea, and a few folks have suggested using the downwash to see what it does and see if it can blow dust around. So in the future, that could totally be possible. Who knows? We'll certainly after the first spin up of the blades, we'll see how much dust moves off the surface, and I think we'll find some cool application. So what's in it? We used a lot of carbon fiber and custom composite layups, and that really helps you keep that really lightweight while still becoming, you know, strong and stiff. As well as a big challenge, you can see the blades are fairly long relative to, and this is an older version of it that we've just been using this graphic for a long time. But yeah, the blades are extremely long. So how do you keep the blades from flexing too much or breaking over such a, you know, long distance? And that really comes from the, you know, the advancements in the, you know, the blade material design. Same, the solar panels made from that material.
What major changes had to be made to the blades to accommodate the much less dense atmosphere of Mars? Was it shape, length, width?
All of the above. Yeah, all of the above. Normally on Earth, there's some differences in blades. You'll see blades will be kind of long and thin. Some of the reason for that is the way the blades interact with the atmosphere on Earth. The air actually keeps the blades from, you know, flapping out of control. It doesn't work the same way on Mars because it's so you know, such low density. So yeah, just making the blades as stiff and strong as possible to keep the, you know, the lifting surfaces from breaking apart was the challenge there. The first trick was can you even lift? And for a long time, a lot of people, I think, and around the world, you know, were dubious that it was possible. But in 2014, they built the little model here, and see, kind of just hop up and down. I'll let the video run because it's actually in the end of it is. You can see what happens. Here, this actually is a very experienced drone pilot trying to fly the helicopter, and you can see the trouble they're having doing that. And you can, you'll see in a second what eventually happens. Let's see. Yeah, there we go. And
Oh no.
So that demonstrates the difficulty of trying to fly by hand. Can you fly a full-scale model with control? As you can see, the wires coming out the bottom. So on board of this is just legs, the blades, motors, I think just a few motor electronics, but all the control, all the power is coming in from outside. And so that happened in the middle of 2016. And I think it's the first time you really hear what it's going to sound like. Just to warn you, I might not be able to hear you when the blades really start going if it's loud enough. So that is the sound that it will sound like on Mars. This is at Mars density. And the little balls on the top are actually a Vicon motion capture system, kind of like the people who do the, movies, like CGI for movies use when you wear the suits with the little balls on them. And this is just for the cameras around the chamber to track the vehicle so we know where it is. We did successive testing with this, some static testing to try to figure out the vehicle dynamics. We did testing on a big swing arm, and this is all in our 25-foot diameter, 80-ish foot tall vacuum chamber that we test most of our large spacecraft in at JPL. And I think we spent a long time in this chamber doing lots of testing, and then that culminated in the engineering model with the first free flight test with everything, kind of Mars-like in it. And you can see at the top of it, there's a cable coming off the top. And again, excuse me if you can't hear because of the sounds. There's a cable coming off the top. That's actually a gravity offload because this helicopter is designed to lift in Mars gravity of, which is 1/3 of Earth. This tether is actually attached to a mechanism that's pulling the helicopter up at 2/3 2/3 the weight of the helicopter. So a helicopter's about 4 pounds. It's pulling up at 2/3 of that. It's like 2.5, 3 pounds upwards. And if you stop flying the blades, if you stop spinning the blades, the helicopter would fall down because that can't actually hold it up. And to demonstrate that it's not actually providing stability for this, you can see that as the helicopter is moving and translating to the side, is actually pulling the cable sideways, trying to fight against it.
In this video, we're going to get started on coding a Mars helicopter video game using block programming. The Mars helicopter Ingenuity is a technology demonstration mission designed to show that a small, lightweight helicopter can fly in the thin atmosphere of Mars. To complete this programming challenge, you'll need to download some files. Now, the link at the end of this video will take you to the website with the files and detailed instructions on how to download the backgrounds and sprites. We're going to use a free programming language called Scratch. You can create an account if you want to revisit and edit your project later, or you can simply click Create to get started. The first thing you're going to need to do is get the helicopter to Mars. Now select Upload a Backdrop from the Choose a Backdrop menu. Browse to the files you downloaded and pick one of the Mars backdrop images. You should see your backdrop image in the stage area now. Next, add the helicopter by clicking Upload Sprite from the Choose a Sprite menu. Select the helicopter sprite that you downloaded. And since we haven't discovered life on Mars yet, let's get rid of the existing sprite by clicking on it in the Sprites window and clicking the X in the corner. Now you need to program controls for the helicopter. The Mars helicopter won't be controlled in real time with a joystick or a keyboard from Earth, but the people who play your game will need some way to control the helicopter. So let's create blocks of code that will make your helicopter fly up, down, left, and right when certain keys are pressed on the keyboard. There is more than one way to code these controls, but let's try starting with the block that says when the green flag is clicked. This will give you more options to control your code as you get further into making your game. Look for an if-then block to add control to the helicopter and figure out what needs to be added to make the helicopter move. Now try looking at the sensing and motion code sections for useful blocks. If your helicopter doesn't seem to be moving after you click the green flag, make sure your code blocks are in a forever loop. Otherwise, the code will only run during the brief moment that you first click the green flag. And don't forget to include code that will keep your helicopter oriented with its rotor on top, no matter what direction it's traveling. If your code is working properly, you should get something like this. Now next, you'll need to add a takeoff location. You can create code blocks that put the helicopter in the same location at the start of the game. Use your X and Y coordinates from the stage area to mark a starting point. Like before, start with the when the green flag is clicked block. If you're not sure what to do next, try looking at blocks in the motion section. As a challenge, consider creating code blocks that make the helicopter start in random spots whenever the game restarts. Now that your helicopter can fly and has a takeoff location, it needs a landing site. The Mars helicopter Ingenuity will start with a straight up and down flight. Later, its flights will become more complex and travel up to hundreds of meters. You'll need to create a landing site for the helicopter. While the helicopter on Mars won't have a landing pad, your game players will need to know where to land. You can draw a landing location with the backdrop costume editor, or you can add a sprite that will serve as a landing target. If you developed a code block to move the helicopter to random takeoff spots, try making code that moves the landing target to a different random location each time the game is started. The Mars helicopter flights could last up to 90 seconds. To add difficulty to the game, create a countdown timer that limits how long players have to get to the landing site. To do this, create a time variable that starts when the game begins and counts down to 0. The timer should be long enough that the game can be won, but not so long that it's easy to win. Success for game players can be the same as success for the Mars helicopter mission. Mission success will be achieved when the helicopter makes its first controlled flight on Mars. So develop code blocks that announce mission success when the game players successfully fly and land the helicopter on the target. And now that you have the basics of your game coded, think of ways you can improve your game or make your code more efficient. Challenge family and friends to play your game and ask them for feedback on how it can be improved. Visit the website on the screen or click the link in the video description to download the required files and see more suggested gaming features you can add through coding. And we'd love to see what you create. Friend or follow us on Scratch at Janet's Planet. Let your mind revolve around this thought: code your way to Mars. And that's the view from Janet's Planet.